So for example here, see this one. In this example, our input image is handed MNIST dataset. Okay, MNIST dataset. It contains handwritten digits. Is a 2. Okay, the size of the image equal to 28 rows and 28 columns, and one channel is there. That is a simply a black and white image. Okay, now a grayscale image. Only one channel is there. Okay, for example here, our aim is you have to predict the whether it is a 0 or 1 or 2 or 9, like that. You have to identify this is your input image and this is your output class labels. What are output class labels? Whether it is a 0 or 1, 2, like that. Okay, now and in order to identify the output value, whether it is a 0 or 1 or 2, like that, we have to apply what happened initially. If it is a ANN, what happened in the ANN? What happened? So it contains 784 features are there. Now here this is contains 784 features. But what happened if it contains more number of features are there, more number of operations are you have to perform in the artificial neural networks. But with the help of our CNN models, we are going to reduce the size of the image, and also we are going to reduce the number of features, and also we are going to reduce the number of parameters in the fully connected layers. That is the purpose of the our CNN model. Okay. So now, so see this one here. After applying the convolution layer, what happened? This is input image, 28 rows, so 28 size of the image, and we are not adding any flattening values. Okay, the size filter size equal to 5 by 5, and then slide equal to 1. Okay, and value, and then we are going to get the value as adding the 1. Okay, that is here n plus 2p minus f by s plus 1. If you apply this one, we are going to get the output image equal to 24 by 24. Okay, then we are going to apply pooling size, pooling operation. Then we are going to get the 12 by 12, that is 24 plus okay 0 minus f is 2 by 2 matrix, and slide equal to plus 1. Okay, that is 24 minus 2, that means 11, 22 by 2, that is 11. 11 plus 1 equal to 12, that is output equal to 12. Okay, like that we are going to get the next output size image. Now here we are going to apply n1 channels, we are going to get the n2 channels, and we are going to get the n2 channels, like that. So after that we are going to get the flattening layer, and then on the flattening layer we are applying the fully connected layer. In the fully connected layer we are going to apply activation function as a Rayleigh as activation function. Then finally we are going to get the output as a 0, 1, 2, like that. So like that we are going to get the apply our models. So this is the one way representation of our this is the different way. Okay, so in the previous example where we are using the 5 by 5 kernel. Okay, here we are using the 5 by 5 kernel, and but here we are using the different types of kernel. We can use any kernel, 3 by 3 kernel. Okay, here using the 3 by 3. Previously we are using the 5 by 5 kernel. So like that we can use different types of kernels in our model. Okay, so but the concept is same only, that is apply the convolution layer, and then apply the pooling layer, apply the convolution layer, apply the pooling layer. So it's a continuously apply so that we can minimize the size of the image. Okay, now so like that we're going to get the your models. Okay, and this is the about your for example, this is the for example here see this one 28 by 28 image is there, and on that image we are applying the kernel size equal to 3 by 3, and field stride equal to 1, and padding equal to 1. Okay, previously there is no padding. That means padding means after applying the convolution also we are going to get the same size image. So here the size of the input image is equal to 28 by 28. Here also we are going to get the output image equal to 28 by 28 only. This is done with the help of padding. Okay, now so like that, based on the different applications, we can apply stride. We can change the values of stride, padding, like that. Okay, but ultimately we are going to get the better output only. So like that, we are going to apply our models. This is one model is there. Okay, so like that we are applying the our convolution models. Now here our aim is we are going to see one case study that is called as a face recognition using the CNN Now here the first step is you have to understand the business problem, then import the library files, then load the data set. The fourth step is data pre-processing. Fifth step is model building. In the model building, we have to apply all our convolutional layer operations. What are different operations are there here? The first operation is called as a convolution operation, then pooling operation, then flattening, then fully connection layer, then output layer. So this is all these five steps are called as a model building. After that, you have to compile the model, and then you train the model, and then test the model. So these are the steps you have to follow in order to implement your CNN model in order to recognize the face of the person. Okay, with the help of your Python code. Okay, now we are going to see the code for this model. So now, in order to run this model, first of all, in my drive, I am placing the different types of images. Okay, different images are there. Okay, um, in my drive, I'm having the one folder is there. That folder contains face recognition using the CNN. It contains the different types of persons are there. That person's images are like original images are there. It contains different images are there like Akshay Kumar images. Okay, Akshay Kumar images, different images are there. Okay, like that we're having the 31 persons images are there, like Vijay images are there, hero Vijay. Okay, different images are there, and like that we are having the Virat Kohli images are there. Okay, different shades of the images are there. Okay, now these are the original images, and also I'm having the test images are there, like faces are there. These are the test images are there. It contains different images of the different persons. Okay, our aim is we have to predict the corresponding, we are giving the one image as input to our model, and we have to predict the corresponding class label of the persons. Okay, now so in order to do this one, first of all, I am in my drive, I am placing all the images of the persons. Okay, now and then I'm going to in my Google Colab. In the Google Colab, with the help of Google Colab, I'm going to run our model. Okay, here in order to run this model, okay, we require the um, NumPy as a we require different library files like NumPy, Pandas, Keras, like that. We require some different things are there. First of all, you have to import the TensorFlow as a TF. TensorFlow import from TensorFlow import Keras, and from Keras.models import to sequential model. What is the meaning of sequential model? Sequential model nothing but you are performing the all the operations in a step by step from the input to the output. So that's why it's called as a sequential model. And from the keras dot layers the import to first operation is conversion to D, conversion to 2D. That means convolution operation we are going to perform the, then we are going to do the max pooling 2D, then dense layer flattening layer, then performing the flattening, then applying the dense layer, and then drop out. So all these are available in the from the keras dot layers. Okay, you have to input all the those things. Then matplotlib is used to plot some graphs, and then from keras dot layers import batch normalization, and in order to perform the pre-processing. Okay, from keras dot pre-processing import image, and from tensorflow dot keras dot pre-processing dot image import to image data generator. So all these different library files are going to be import first of all. Then you have to read the data set. Okay, for this they read the data set. Yeah, my data set already placed in the our Google Drive. Okay, drive. Okay, so you have to mount the drive with the help of from Google.colab import drive, drive.mount. here the location of my drive equal to slash content slash drive. Okay, with the help of that one, our we are connected with my drive. Okay, where my data set are located. Okay, now. So from that we are going to read the data set. Train underscore directory equal to slash content slash drive my drive face recognition using the CNN original images and slash original images. That means where we're having the all my original data set. Generator is there. Generator is used to generate the new images. Okay, image generator. Train underscore ds equal to generator dot flow from the directory. Here the train directory and the time directory nothing but your original images are there, and the target size equal to 224 by 224, batch size equal to 32. That means 32 images are belonging to one batch. Okay, like that we are going to divide all the images into different batches, and each batch size contains 32 images. Okay, now. So after that, if we execute this one, what happened now? Totally 2,562 images are there. All contains 31 different persons images. Okay, now here it contains the different classes are there. The list of classes are there here. Okay, just wait. After that, a class is equal to list of train underscore ds dot class underscore indices dot keys. If you do this one, you can get all the 31 different person names, and then we are going to generate the model. The model equal to sequential model here, and then the first step of this one is equal to you have to perform the two operations. The first operation is a convolution operation, then followed by the pooling operation. These two steps are performed multiple times in order to minimize the number of operations. Okay, so here the model dot add of convert 2D. Convert 2D nothing but a convolution operation, and the number of neural layers are 32 layers are there, and the kernel size equal to 3 by 3. And what is the activation function applied here? That value is a activation function. The input size of the shape equal to 224 comma 224 comma 3. That means size of the image is 224 rows and 224 columns and 3 channels. That is red, green, blue channels. Okay, now RGB channels. Okay, so this is the input. On this input, we are applying the kernel size 3 by 3 and the activation function equal to relu, and defaultly we are applying the padding equal to none. That is valid. We are not providing any value here. Okay, that's why default value equal to valid. That means we are not adding any value to our input image, and std equal to 1. Default to std value equal to 1. Okay, now. So model dot add. Okay, then after that we are going to apply max pooling. Max pooling 2D equal to model dot add of max pool 2D. Pool size is equal to 2 by 2. The size of the stride equal to 2, and pooling size of the image also kernel size also 2 by 2. Okay, after that we are going to apply batch normalization. We are going to get the better values after applying the batch normalization. After that, once again we are going to apply our what we call convolution and pooling. So here we are applying the model dot add of convert 2D. 64 kernels are there. Okay, kernels are there, filters are there, and then here the kernel size equal to 3 by 3 and the activation function equal to relu. The whatever the output of the here max pooling, that is the input for this model. Okay, this convolution 2D, and then we are applying the model dot add max pooling 2D, pooling size equal to 2 by 2, and then batch normalization. So whatever the output is there, that is the output is given to input for the, or once again we are applying the max pooling 2D. Okay, model dot add convert 2D 64, and kernel size equal to 3 by 3 and activation function equal to relu, and model dot add max pooling 2D pooling size equal to 2 by 2, and model dot add batch normalization. Okay, like that we are applying the different types of convolution 2D convolution operations under max pooling size. Okay, max pooling. Then we are going to get the, after that we are going to apply what we call dropout is there. Dropout is to remove some unnecessary information from the our neural networks. Okay, then apply the flattening layer model dot add of flatten. Then we are going to, after that we are going to get the dense layer. What is the dense layer? Dense layer nothing but your fully connected network. What we call fully connected network. It contains we're having the 128 neurons are there, and in the hidden layers we are going to use the activation function as a ReLU. So suppose we want to add the one more hidden layer. Okay, at that time we are going to use the model dot add of dense layer of 64. Like that we can add a number of neurons here, and the activation function is ReLU. Like that we can add a number of hidden layers between the input and output layers, and then finally we're having the on output layer. It contains model dot add of dense of length. Here we're having the 31 class labels are there. That's why we are using the 31 neurons in the output layer. In order to find out the number of classes, here we are using the length of classes. Length of classes of classes, that means 31 neurons are going to use it in the output layer, and the activation function in the output layer is a softmax. Why? Because it is a multi-class classification problem. That's why in the output layer we are going to use the activation function as a softmax. After that, we are going to compile the model. So model dot to compile. Last function is equal to categorical cross entropy, and optimizer equal to Adam, and metrics equal to accuracy. So like that we are going to apply all the compile the model. Now we are going to see the model summary. Model equal to sequential model. So here we were applying the multiple times convolution 2D, max pooling, convolution 2D, max pooling, convolution 2D, max pooling. All those things are going to be up. See, we can see in the one table like structure. Okay now. So finally we are applying the dropout, and the flattening layer is there. Okay, the flattening layer is there, and then applying the dense layer, and dense layer nothing but a fully connect layer. This is one type of hidden layer is there, and then finally we are applying the output layer. Okay, in the output layer we are having the 31 neurons are there. Why you are having 31 neurons? It's a 31 different class labels are there. That's why you're getting the length of classes. Okay, 31 neurons are there in the output layer, and in the output layer we're having the we are applying the softmax as a activation function. Okay now. So like that we are applying the or compile the model, then then train the model with the help of a model dot fit. For this train fit function we are applying the training data, train underscore ds, and number of epochs are equal to 10 epochs are we are going to upload here, and the batch size equal to 32. The each batch contains 32 images. Okay now. And if you apply run this one, okay, initially what happened, the accuracy is going to be very low, and the loss is going to be very high. After applying all the iterations, okay, all the iterations, the accuracy is going to be very high, and the loss going to be decreases. Okay, so this is the way we are going to train the model. After that, if you want to see the image of the, we are reading the input image from the input, and then find out the class level of the corresponding person name. Okay, so for this one, from the TensorFlow dot keras dot utils, import to load underscore image, and try image to underscore try image to array, and then here in order to define this one, definition predict the image, we are reading the image path. Okay, and colon, okay, image equal to load underscore image path, and the target size equal to 224 by 224 by 3, and you plot the image, the what are the image we are reading, that is we are going to show plot dot show, and x equal to image to we are converting all the image value into pixel values. Okay, single value image underscore to underscore array with the help of image value, and x equal to np dot expand dimensions x comma x equal to 0, image equal to np dot v stack of x, and predict the value of equal to model dot predict images batch size equal 32, and predict the print the actual value plus image path dot split slash okay -1, and dot split value with the help of index value equal 0, and print predicted value uh, the classes, what are the classes are there, we are having the number of classes are there. So np dot argmax predict the corresponding value. So if we are defining this function, if you run this function automatically, okay, if you are providing the image value predict image value, okay, suppose we are giving the input image as a image value, So we are going to predict the output of corresponding class label as a name of the person is a Don Johnson. Okay, na Johnson of the name of the person of the image. So like that we are going to develop the model. Okay. So here based on the uh, convolution and pooling only we can develop your own models. Okay. So like that we are going to predict the faces of the our input image. So this is about CNN models. If you have any doubt, please ask me.